Yeah. Yeah, good evening all. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 8 plus years of experience in big data, Hadoop and Spark environment. So as part of today's demo, just I'll be covering the following topics, right? What is big data? Why Hadoop? Drawbacks with the current databases, Hadoop and PySpark advantages, and Hadoop and PySpark job market, right? Yes. So just before I go with the actual things, let me show you that what I'm going to cover as part of this, right? Hadoop and PySpark. Yes. Yes. Big data Hadoop, like introduction to this. What is Hadoop? Need for Hadoop, sources, challenges, databases in Hadoop, advantages of Hadoop, Hadoop ecosystem. And Hadoop, we have got Hadoop for distributed file system for storing that huge data, right? We have got a file system called Hadoop distributed file system, discussing about that HDFS file system. We have got a different the architecture like name node, data node, secondary name node, job tracker, task tracker, and MapReduce is a parallel execution model for processing, right? Yes. And in brief on this MapReduce and Scoop, it's for import or export operation for importing or exporting, importing from databases to Hadoop and exporting from Hadoop to databases. And during that import operations, we can perform various operations, importing, exporting, filtering, transformations, grouping, merging, all that you can perform. Yet another resource negotiator, yet another resource negotiator, right? From Hadoop 2 version onwards, we got some architectural changes, right? Yeah. Speculative execution, speculative jobs, speculative tasks, yarn architecture, yarn processing, I'll be discussing, like, and NoSQL database. You need to have the idea about at least one NoSQL database, different types of NoSQL. I'll be discussing one NoSQL database, HBase in brief, right? Yes, HBase performing these CRUD operations, creating tables, and HBase and Hive integrations, the storage handlers for it. And one more, the important component of Hadoop, Hive. Hive metastore means making the data structure and performing some kind of querying. Hive query language, we say, similar to SQL, we have got HQL. Loading data from these local files, HDFS files, uh, unstructured, working with unstructured XML data, JSON data, URL web log data, UDF, UDAF, UDTF, right? And partition table, non-partition tables, partitioning, bucketing, indexing, right? Performance tuning mechanism through Hive, right? Yes. That is what the Hadoop components like Hive, Scoop, HDFS, MapReduce, these are going to be discussed. And coming to the PySpark, my more concentration will be on this PySpark. All right. Yes. More time we'll be spending on this PySpark. PySpark introduction, need for PySpark, real life usage, PySpark session context, repartitioning, broadcast variables, accumulators, RTD computations, the steps in RTD's computations, persistence features, actions and transformations, various persist options, and PySpark 4 computation, increasing the number of partitions, groupings and aggregations, and various different inbuilt actions and transformations of this RTD. And coming to this data frames, PySpark SQL data frames, right? And making data structured and working with different data frames API, dataset API, right? Creating a data frame, converting to RTD to data frame, structure type, struct field, row class, column class, select, collect which column, with the column renamed, variant filter, drop and drop duplicates, order by and sort, group by, union all, union by name, UDF, flat map for each, all these functions, right? That's for data frame functions and PySpark SQL functions, aggregate functions, window functions, date timestamp functions, JSON functions, and built-in functions of PySpark built-in. No need to write huge codings here. We have got many built-in functions when exp, lit, split, to date. All these are the various PySpark built-in functions with some working examples. And PySpark external sources working with Hive, working with SQL statements, Spark and Hive integration, Spark and MySQL integration, working with CSV, working with JSON transformations and actions, narrow and wide transformations, adding of new columns, new rows, handling nulls, window function, creating of tables from data frames, right? Deployment modes, right? Local mode, cluster mode, right? And PySpark application stages, drivers and executors, building Spark applications, deploying Spark apps, performance tuning, and PySpark streaming concepts, integration with Kafka, right? Yeah, next. So this is regarding PySpark in brief we'll be discussing, and also people if that who choose right entire package right in that with Python without Python right. If you got with Python, Python also going to be covered because PySpark total coding goes in Python. When Hadoop is discussed at the same time, you'll be updated with Python, right? Yes, when Hadoop is going parallelly, big data Hadoop is discussed, and parallelly Python will be covered. Once PySpark is started, by the time at least 60% of the Python gets completed, right? So in the Python, with that too in brief, Python in brief, it will be discussed. Basics, applications, advantages, versions, flavors, modes, editors, IDs, data types, constants, variables, comments, type conversions, escape sequences, operators, different IDs working with the Anaconda, Prompt Navigator, Jupyter Notebook, Spider, Eclipse, PyCharm, right? Different IDs I'll be showing you. Flow control statements, looping statements, strings, collections, lists, tuples, sets, dictionaries, functions, modules, modular programming, right? Packages, errors, types of errors and exceptions, file handling, working with different files, file formats, object-oriented programming concepts in brief, class, object, inheritance, polymorphism, their types, regular expressions, right? Extracting data from the given data, database connectivity, Python database connections, date and time, OS, advanced concepts like iterator, generators, closures, and decorators, graphics, working with Excel workbooks, data analytics, introduction to data science, Pandas model in brief, NumPy model in brief, and matplotlib plotting and visualizations, right? These 30 topics in Python will be covered. And this is, yes, this is Python, this is PySpark and Hadoop. And also you'll be given knowledge on Linux. Everything goes in Linux environment, right? Yes, Linux also is going to be covered. Means the basic, what all the commands, what all the knowledge required for this Hadoop that will be discussed, right? Yes. So yes. So Hadoop, PySpark, Linux, and Python is a package, right? So the fee structure is 15,000 for this Hadoop, PySpark, Linux, and Python. Python you will be attending Monday to Friday. The classes will be from Monday to Friday, any regular. But this is weekend Hadoop, PySpark, and Linux will be the weekend classes. 2 hours on Saturday and 2 hours on Sundays. Totally goes for 12 weekends. Yes, if you already have knowledge in Python, the fee structure will be 12,000. Without Python, with Python, it will be like 15,000, right? Total in brief, it will be discussed. You'll be getting this session video every day session videos for all this. Clear notes, assignments and tasks, and a WhatsApp group will be created for technical discussion where you can directly interact with me. Right? Yes, coming to this demo, right? Yes, what is big data? Why we need to go for Hadoop? Drawbacks with the current databases, Hadoop and PySpark advantages, and Hadoop and PySpark job market, right? Yes. Currently, if you see big data, right? Huge volumes of data. The name itself saying like huge volumes of data. So data storage units, you can see, right? KBs, MBs, GBs, terabytes, petabytes, exabyte, zettabyte, etabyte, and sottabytes. But you should have seen KBs, MBs, or GBs, or TBs of data. You should have seen, but beyond the TBs, right? Today, data is generated in petabytes. Data is generated in petabytes, right? But examples of petabytes of data generation. So the demo goes for 2 hours, right? It will be up to 7:30. Yes, 2 hours. Yes. Databases, right? Currently, we have got databases like Oracle, MySQL, DB2, SQL Server, right? They are used for online transactional processing. We have got some specialized databases like Teradata, Netezza, Vertica. They are used for analytical processing. They're used for online analytical processing for data warehouse purposes, right? These databases are the specialized databases. Okay, I'll discuss the drawbacks with the databases, but before that, they can handle data up to some extent, but once petabytes of data are beyond that, cannot be handled by this. So as a solution to all the storage level problems and processing level problems, right? We have got framework called Hadoop. So before I go with this, this is your data in the entire real world. This is your data in the entire real world. This is the data, right, which got generated from the last 50 years. Assume from 1974 to 2024. But if you see the last 10 to 15 years of data compared with the, yes, if you compare that last 10 to 15 years, means from 2014 to 2024, nearly 80% of the data what we see in the current world has been generated from the last 10 to 15 years. Only 20% we can see from the last previous 40 years. Reasons for this huge data generation from the last 10 to 15 years means because of usage of technology, usage of internet, usage of smartphones, right? Yes. As day by day data is increasing enormously, right? So from what are the main sources from where we are going to where the data is getting generated from, right? Three sources, mainly three sources from where this huge data is getting generated. Social data, machine data, and transactional data. Social data means data which got generated from social websites like Flipkart, uh, Facebook, all this, right? Machine data means data which got generated by reading or scanning the barcodes, RFID chips, right? Such kind of data we call like machine data. For example, when you go to a shopping mall for the items you purchase, right? You get a bill. A bill is going to be generated by reading that barcodes after scanners, right? Such kind of data we call like machine data. Transactional data from day-to-day operations like telecom transactions, banking transactions, right? And this huge data, that data is going to mainly take the three formats or three types. They're going to occupy three formats, right? Or three types of data, right? Structured data, unstructured data, and semi-structured data. Structured data means which is organized in the form of rows and columns in a structured format like database tables, Excel files, all this, right? And semi-structured means which is not fully structured, which is not fully unstructured, like XML files, JSON files, right? Unstructured data, right? Like short messages, articles, images, videos, all this, right? But the biggest challenge today, right? How to handle this unstructured data, storing and processing it. Databases can handle only structured data, but unstructured data, semi-structured data, storing and processing it, right? So as a solutions to all this, right, we have got a framework like Hadoop. Yes. Hadoop, right? So as data is increasing enormously day by day, we need to have proper storage systems and also processing system, right, to store and process this. Hadoop provides two services. It is used for huge data storage, petabytes of data, and for huge data processing in quick time, right? Today, data is generated, huge data is generated, right? I mean, most of the applications, they are generating data, huge data, right? Like Facebook. In a minute, what is the data generated by Facebook, right? It will be in petabytes of data, right? Or even YouTube, what is the data, means what is the storage capacity required to store all the videos, right, in YouTube. Twitter tweets keeps on generating. Google queries, right? Google queries, everyone, they are querying in the Google, right? What is the data generated by Google? It will be in petabytes. Bank transactions, telecom transactions, e-commerce transactions, Flipkart or Amazon transactions. Everywhere we see like huge data, right? So wherever you want to store and you want to process that huge data, go for this Hadoop framework. So for storage, it doesn't, okay. Uh, you got some processing technologies. If you talk about any technology, right, C or C++ or Java or .NET, they are meant for either any technology, they're meant for either storage or for processing. C, C++, Java, .NET, they are meant for processing. Or if you take Oracle, MySQL, DB2, SQL Server, all these they are meant for storage. Any technology meant either for storage or for processing, but Hadoop performs both storage and processing. For storage, we have got, it doesn't use any database for storing its data because databases has got some drawback. Despite of those drawbacks, Hadoop doesn't use any database. It is going with a file system, Hadoop distributed file system for processing. File processing, we have got map reduce. Is going with an execution model, parallel execution model called map reduce. Currently, we are using Spark, right? Fine. Hadoop provides two things for storage and processing. Yes, for storage HDFS and for processing map reduce. When Hadoop is able to perform both storage and processing, then what is the necessity of these technologies? Do you think they will go away from the market? No. Hadoop is meant for batch applications. Hadoop is meant for batch applications. Clearly understand, not for online applications. For a single transactions or two transactions, Hadoop not required. For millions and trillions of records, there are two types of applications. So Hadoop providing two services, storage and processing. Hadoop is meant for batch applications. There are two types of applications: online applications, batch applications. User interactive applications. Online applications, right? User interactive applications. Here, user gives the input. Here, user gives the input. Online applications, compulsory user has to give the input. User interactive applications. Making a online payment, user is involved. Booking a movie ticket, user is involved. But batch applications, user is no way required. User is no way involved. User non-interactive applications. But what all this Hadoop or batch applications, user is no way required. Railway ticketing PNR status. Your status is 200 now. After 1 hour, it is 150. Tomorrow, it is 100. Tomorrow evening, it got confirmed. Right? User is not performing anything here. It is getting in the automated fashion, right? So generating credit card statements for millions of customers. Your user is no way involved. and phone bill statements generations, right? For all this user not required. Most of these bank applications are financial applications or batch applications, right? I was saying drawbacks with the current databases. Why Hadoop? Okay, before I go with that, right? Drawbacks with the current databases. Most of the databases, we have got less storage. They cannot handle unlimited or huge data in petabytes, right? No parallel processing in most of the databases. Yes. If volume increases, speed decreases in this databases, right? Example, total, if you want the total amount from sales one, total amount from sales two, total amount from sales three, three different tables. They've got a three. In the first table, you got only 10 records. Second one, you got 1 lakh records. Third one, 1 crore records. 10 records, 1 lakh records, 1 crore records. Okay. Total amount from sales one, sales two, and sales three. 10 records, 1 lakh records, 1 crore records. Observe this. Which query is going to execute faster among these three? The first query, right? Because total amount of 10 records as compared with total amount of 1 lakh records. Total amount from 1 crore records. Query to query, query to query, the data is increasing. Speed decreases, right? And even one more drawback. Complexity increases. Speed decreases. If complexity increases, speed decreases, right? Select total amount from sales one. Select total amount from sales one. 1 lakh records. Select average amount from sales one. Standard deviation of from sales. Same table, but total amount, average amount, standard deviation of. Which query executes faster among these three? Obviously, the first query, right? Because average amount is a two-step process. First sum has to be calculated, next average has to be calculated. As compared to the first query, second query taking more time. Third query, standard deviation, lot of internal processing is required. As compared to the first and second, this last one takes more time. Yes. And the major drawback with the databases, they can handle only structured data. Databases, they can handle only structured data. They cannot handle unstructured or semi-structured data, right? Yes. Drawbacks with the current database. So despite of these drawbacks, Hadoop is not going with these databases for storing its data. Rather, it is going with a kind of file system called Hadoop distributed file system. Right? And one more thing, Hadoop doesn't follow client server architecture. Hadoop doesn't follow client server architecture. Hadoop follows master slave architecture. Single master and multiple slaves, right? Single master and multiple slaves. This is master node. Slave 1, slave 2, slave 3. Slave 1, slave 2, and slave 3, right? This we call it like slave nodes, or we call it like data nodes. Data is stored by the slaves and data is processed by the slaves. Slave nodes are data nodes, right? Slave nodes S1, S2, S3. Data is stored by the slaves, data is processed by the slaves. Yes, if you take any file, f1.txt file, in Hadoop, data is stored in the form of files. In databases, it is stored in the form of tables. In Hadoop, in the form of files. This file, a huge file, right? Assume the size is 2 TB. But each system capacity 1 TB, storage capacity 1 TB, 1 TB, 1 TB. This 2 TB file cannot fit into any of these systems, right? This 2 TB cannot fit into any of this. So it will be splitted into smaller parts. It will be splitted into smaller parts. Each part is stored. Each part is stored. Means here two things you can observe. Data is distributed. Data is split into smaller parts. Data is distributed and data is processed by multiple slaves parallelly. Okay. So data is divided into smaller parts. Each part is stored across multiple systems and are processed parallelly, right? Okay. So this entire thing we call it as a cluster. Cluster means a group of nodes connected in a network. Group of CPUs, so nodes connected in a network. Okay. So Hadoop cluster, group of nodes CPUs connected in a network. There are two types of nodes. Master node, within that we have got name node. Slave node, within that we have got data node. I'll discuss about these things later. Master and slave, right? Yes. Hadoop advantages, right? Unlimited data storage is possible. Unlimited data storage, right? Horizontally unlimited scalability. Unlimited data storage is possible, right? Horizontally unlimited scalability. Um, Very high speed. Okay, what do you mean by unlimited data? Okay, horizontally unlimited scalability. So unlimited data can be stored, right, in this Hadoop. Um, if you're running a business, right? You're running a business, you've got some slaves. You're running a business with some 10 slaves, S1, S2, so on, S10. If your business has increased, your branches have increased, your customers have increased, your branches have increased, your data also increased. You cannot go with the same number of systems. Horizontally, you should keep on increasing the slaves or the systems, right? Horizontally, unlimited number of systems can be added. There is no limit. You can keep on adding the number of the systems. very high speed processing because of parallel processing, right? So data is distributed across multiple systems or the slaves and are processed parallelly. Can handle all varieties of data. So can handle all varieties, structured, semi-structured, and unstructured. And open source. Hadoop is an open source. No licensing is required. Most of these Hadoop products are from Apache. You can just download from the Apache Mirror site and you can install it. Commodity hardware means Hadoop doesn't mean that you need to have very high configured systems. No, Hadoop can run on any hardware, right? Any systems, commodity hardware, right? So these are the main advantages: unlimited data storage, very high speed processing, handling all varieties of data. Yahoo has conducted a test. You can check this, right? Yahoo has conducted a test. Yes. To check the speed of different databases. It has taken a table of 1024 columns. The task sorting based on 16 columns. Generally, we'll sort by a single column, sorting based on age, sorting based on department numbers, sorting based on years. But here, sorting based on 16 columns. Time taken by the different databases. Oracle has taken nearly 3.5 days. MySQL has taken nearly 6 days. Teradata has taken nearly 4.5 hours. Teradata has taken nearly 4.5 hours. Netizen has taken 3 hours. Hadoop just taken 2.4 minutes. So databases, Oracle and MySQL, they have taken days of time. The specialized databases like Teradata, Netizen, used for data warehouse purpose, they have taken nearly 4.5 hours, 3 hours. Hadoop has taken 2.4 minutes. But this is the Hadoop speed in minutes. But PySpark, what we are going to discuss, it's 100 times faster than Hadoop. Then see the speed of this PySpark, right? Why databases like Oracle cannot support unlimited storage? Okay. Why databases like Oracle can't support unlimited storage means there is a limit on the number of slaves or the CPUs, right? Oracle can go with the maximum 256 nodes CPUs. They even Oracle can have multiple systems. Maximum it can go with the 256 nodes or CPUs. MySQL can go with 54 nodes. MySQL can go with max 54 nodes. MySQL Express 256. DB2 also 256. SQL Server 256. All these databases, maximum 256. Beyond that, they cannot support. Okay. Teradata, vertical. If you talk about this Teradata and vertical, they can go with 512, 512 each, right? But currently they are supporting 1024 nodes or CPUs, right? Teradata and Vertica. Yes. But there is no limit on the number of slaves that Hadoop can have, right? Unlimited slaves. But there is no limit on the number of slaves that Hadoop can have. Unlimited number of slaves. But there is a limit for all these databases. But even if we talk about Oracle, right? If it has reached this 256 nodes, it cannot support data further. And even the performance of the system degrades if it has reached 256, right? Just like your mobile phone. If 64 GB is given, if all the 64 GB is filled, the performance of the phone degrades, right? Sometimes it won't even start. The same way, this databases. But there is no limit on the number of slaves that Hadoop can have, unlimited slaves. Yahoo, when first time implemented Hadoop in the year 2005, it went with 4,000 nodes for storing its data, 4,000 CPUs. Currently, Yahoo going with 12,000, sorry, 12,000, right? Nodes. When first time, yeah, Facebook, when first time implemented Hadoop, it went with 8,000 nodes or CPUs, right? For storing its data. Currently, Facebook going with 42,000 systems, right? Or CPUs for storing it. Okay. So Hadoop is proven in the market. So storage point of view, there is no limit on the number of slaves, but for other things, you have got a limit. And also processing point of view, right? Very high speed as compared where they have taken days and hours, right? And what are the Hadoop ecosystem components that I am going to discuss as part of this course, right? Yes. HDFS meant for storage. So Hadoop ecosystem components means they have what I'm going to discuss as part of this, like HDFS meant for storage, MapReduce meant for processing, Apache Hive. MapReduce is a parallel execution model for processing. Apache Hive is one more processing component of Hadoop. Like it's a kind of data warehouse kind of an environment in Hadoop framework. Here we use a language called HQL, which is similar to SQL. That's meant for processing data warehouse means. It has got a language called HQL, Hive Query Language, which is similar to SQL, right? Yes. Scoop, SQL plus Hadoop, SQL plus Hadoop, right? For import or export operations. For import or export operations. For importing data from databases to Hadoop and for exporting data from Hadoop to database. From SQL and Hadoop only, right? The first two characters and this last three characters forms the scoop. The first two characters of this, last three characters of this forms, right? NoSQL databases. Generally, SQL databases, right? They have got schema. We have got schema, right? From first record to last record, same number of fields has to be maintained. But in the case of NoSQL, random access, schemaless behavior, record to record, different number of fields can be maintained. Yes, record to record, different number of fields can be maintained. So, as part of the course one, NoSQL database, HBase will be discussed. Yarn, yet another resource negotiator. Yes, Flume or Kafka. Flume Kafka, right? Yes. So I'll be discussing about streaming technologies also, right? Like Flume or Kafka, like that is streaming data, data which keeps on generating, data which keeps on incrementing. Such data we call like streaming data. That is, we have got technologies like Flume and Kafka for capturing this streaming data and processing them, right? And Zookeeper controls and coordinates all the other components what we have discussed, right? These Hadoop components for giving connections, connection establishment with these things. And the major part PySpark, right? For a very high speed processing in memory computation, we say, right? Spark core programming, Spark SQL programming, Spark machine learning, and Spark streaming. That is what I'm going to discuss, right? Okay. Spark, okay, PySpark, right? Just I'll take 2 minutes to say the importance of this PySpark. So advantages, the job market. Yes. So PySpark, it is a open source distributed cluster computing environment, right? So it is a general engine, this Spark or this PySpark general engine for big data analysis, for processing and computation, right? Necessity of PySpark, I can say it's a Python API. PySpark is a Python API to use Spark. So it is the lightning fast technology, right? That is designed for very fast computation. It's a demanding tool for all the data engineers to work with bigger data sets. It's used for running distributed SQL, for creating data pipeline, for ingesting data to databases, ML, running ML algorithms, graph algorithms, streaming. This PySpark where for huge data, from that huge data which consists of hidden patterns, market trends, customer preferences, unknown corrections, we need to extract the valuable information from this raw data, right? So we require an efficient tool for performing different types of operations from this huge data. So PySpark is one of the flexible and scalable tool to crack this big data and gain benefit from it. So PySpark combining a Python and Spark is a very efficient way for the world of big data. And Apache Spark community came up with this tool called PySpark. It's Python API for using Spark. Okay. Now, so Hadoop is meant for storing data and processing data, right? How exactly data stored? How exactly, right? As understand this, how exactly data is stored? How exactly data is stored? Now try to understand now how this data and processing is going to happen within the Hadoop environment I'm going to discuss. How exactly data is stored in Hadoop. Data is stored in the form of files. In Hadoop, data is stored in the form of files. Each file again, subdivided into blocks, subdivided into blocks. Default block size. Default block size 64 MB. In latest version, it is 128 MB. Default block size 64 MB. In the latest versions, it's 128 MB. Okay, fine. For example, if I take a file f1.txt file, f1.txt file, okay, think that it's a file f1.txt file. The size is 200 MB. Think it's a banking data. It has got some banking data, right? Try to understand this. In this f1.txt is divided into smaller parts. Any file in Hadoop will be divided into smaller parts. Into how many blocks? Default block size, assume default block size. Take it as 64 MB. Assume default block size is 64 MB. We can have our own block size also. By default, it will be 64, 128. But if you want to set our own block size, we can also set our own block size also. We can configure. Block size means the file is divided into equal blocks. Into how many blocks? Into how many blocks this file is divided? Number of blocks equal to file size. File size by default block size. Two hundred by 64. 4 blocks. Two hundred by 64, 4 blocks will be. 4 blocks means observe. B1 block, B2 block, B3 block, B4 block. In B1, 64 MB. B2 also 64 MB. B3 also divided into 64 MB. Means how the file is divided into 64 MB block. And B4 only 8 MB, right? Means 200 divided by 64, 64, 64, 192. In the B4, 86 MB free, like 56 MB free, right? 56 MB free right here. S1 stored in S2, stored in S3, stored in S4. S1, S2, S3, S4. Means system 1, system 2, system 3. The slave 1, slave 2, slave 3, slave 4. See, data in Hadoop, data that is the file divided into multiple parts. Each part we call it as a block. Default block size, assume 64 MB. Into 4 blocks it is divided. 4 blocks stored in 4 systems. Okay, that's fine. Now, f2.txt, I got a file, f2.txt file. It has got 192 MB. F2 has got 192 MB. Think this is telecom data. It has got a telecom data, right? Yes. Here also, right? Number of blocks equal to file size by default block size. Yes, I'll copy the same thing. One 92 by 64 means exactly 3 blocks, right? Exactly 3 blocks. Here B5 I'll say, B6 I'll say, and B7 I'll say. This is not present. B5, B6, B7, 64, 64, 64, right? Stored in S5, S6, and S7. They are stored in three different systems, S5, S6, and S7. Hmm. Now here I have got a query, right? Why B5 when 56 MB is free? When 56 MB is free, B4, why B5 data is not stored? In B4, if 56 MB is free in B4, why B5 data is not stored in B4? Okay, for example, I want to retrieve, for example, retrieving f1.txt. Assume f1.txt I want to retrieve. f1.txt if you want to retrieve means which blocks? It has got how many blocks? B1, B2, B3, B4. In 4 systems, 4 blocks I need to retrieve. B1 plus, B2 plus, B3 plus, B4. If B5 stored in B4, assume if B5 stored in B4, then observe B1 size will be 64, B2 size is 64, B3 size is 64, B4 8 plus 56, 56 MB of f2.txt. Total equal to 256 MB. 256 MB. But actual file size is 200 MB. means 56 MB, means 56 MB extra you got. The actual file is 200 MB, which is wrong computation, right? But actual file size is 2 MB, which is wrong computation. You got 56 MB of telecom data in this. Whenever I'm trying to retrieve banking data, you got 56 MB of telecom data, which is wrongly computed. Okay. Now, so every file should have dedicated number of blocks. So every file will have dedicated number of blocks. Design principles. Design principles with respect to HDFS. HDFS blocks. Design principles with respect to HDFS blocks. Design principles with respect to HDFS blocks. First one, every file should have, every file should have dedicated number of blocks. In a single file, in a single block, in a single block, in a single block, no two files data to be stored. Yes. In a single block, no two files data to be stored, right? All the files have equal value. All the files have equal value. All the blocks have equal value. Sorry. See, 64, 64, 64, right? Except the last block. Yeah, sorry, here 64. Okay, all the blocks should have equal volume. All the blocks should have equal volume, except the last block. All the blocks should have equal volume except the last block. Okay. We can also configure. Okay, now I'm going to discuss three cases, right? Try to understand three cases. Case 1, the number of blocks equal to number of slaves. Number of blocks equal to number of slaves. Full parallelism you get. Very high speed you get. Number of blocks assume 3. Slaves also 3. Assume blocks B1, B2, B3. S1, S2, S3. F1.txt file. Assume the size of this file 192 MB into how many blocks? Number of blocks 192 by 64. 3 blocks. You got 3 blocks. B1, B2, B3. 3 blocks. Assume that you got some 30 lakh records. 10 lakhs in this, 10 lakhs in this, 10 lakhs in this. Means your data, it has got totally 30 lakhs in that it is distributed across the 3 blocks. Your file is divided into 3 blocks, B1, B2, B3. How this is going to be stored across the cluster? This is the master. These are the slaves. These are the master. These are the slaves. Assume S1, S2, S3. In S1, B1 is stored. B2 is stored in this S2. B3 is stored in this. This is a master node. Within the master node, we have got a name node. Name node maintains the metadata, means data about data. Actual data is stored within the slaves, but metadata is stored within the name node. F1.txt divided into how many blocks? B1, B2, B3. Where B1 is stored in S1, B2 in S2, B3 in S3. Yes. This is how exactly the data is divided into blocks stored across multiple systems, right? This is how the data storage is happening. Data processing, right? Your job is to process f1.txt file. Job always will be divided into tasks. So job is to process f1.txt. Job divided into tasks. Into how many tasks? Number of tasks always depends on number of unique blocks. Number of unique blocks, how many? 3. So 3 tasks, T1, T2, and T3. T1 task is executing this B1 block. T2 task is for executing this B2. T3 task is for executing this B. Job to process f1.txt divided into 3 tasks. T1, T2, T3. T1 task is for executing V1. T2 task is for executing B2. B1 10 lakh records. T2 task is for executing B2 10 lakh records. T3 task is for executing B3 10 lakh records. Now, who should execute this T1 task? Which system has to execute this T1 task? Yes, You unmute yourself and you can keep responding, right? Yes. Want the sessions to be interactive. Who should execute this T1 task? Which system? S1, S2, or S3? T1 is nothing but executing B1. T1 is nothing but executing B1 10 lakh records. 10 lakh records in this, 10 lakh in this, 10 lakh in this. Hmm. One second. Okay. Who should execute this T1 task means S1 only should execute. There is no other choice because T1 is for executing B1. B1 is present in S1. So S1 only should execute. Who should execute this T2 means S2 only should execute. There is no other choice. Who should execute this T3 means S3 only should execute. There is no other choice. Okay. T1 task executed by S1, T2 task executed by S2, T3 by S3. There is no other choice, right? Because S1 is storing B1. So to execute this B1, T1 task. S1 executing. S2 executing this B2, 10 lakh records. That is T2 task. S3 executing this B3, 10 lakh records. That is nothing but T3 task. Yes. So here observe three tasks. Three tasks, right? T1, T2, T3 are executed parallelly. Are executed parallelly by three slaves. Three tasks T1, T2, T3 are executed parallelly by three slaves S1, S2, S3. So there is no task is in the waiting state. All the three tasks by the three slaves parallelly. That's why very high speed, full parallelism, right? Yes. Observe this case two now. In which case the speed will be less. Observe this case two. Observe. Number of blocks is greater than number of slaves, number of systems. 4 blocks, 2 slaves. Here B1, B2, B3, B4. S1, S2. F1 dot txt file, 230 MB. Default block size equal to 64 MB. Into how many blocks? Number of blocks. Try to answer, right? Number of blocks equal to 230 by 64 means 4 blocks. B1, B2, B3, B4. How these 4 blocks are stored across this cluster? This is the master, these are the slaves. Only 2 slaves I said, right? Yes. Assume you got S1, S2. This is name node stores the metadata information. Master node or this within that master node, name node stores the metadata. So B1 here, B2 here, B3 here, B4 here. 4 blocks distributed across 2 slaves. Now here it maintains the metadata water f1.txt. This master node or this name node, which block is stored in which slaves, the total information will be available. Tomorrow, if you want to retrieve, then only those blocks will be combined. B1, B2, B3, B4. B1 in, B2 in S2. B4 in S2. Okay. B1, B2, B3, B4. 4 blocks in 4 slides. S1, S2, S3, and S4. Okay. Now data processing. Job to process f1.txt. Job always should be divided into tasks. Job will be divided into tasks. Number of tasks always depends on number of unique blocks. I'll say why I'm using the word unique. How many blocks? 4 blocks. Means 4 tasks. T1, T2, T3, T4. Yes, observe this job to process. We have what? T1 task, T2 task, T3 task, T4 task. For executing B1, T2 task select. For executing B2, T3 for executing B3, T4 for executing B4. Sorry. Yes, same thing. Sorry. For executing B3, for executing B4, right? Who should execute this T1 task? Now, everyone try to answer. Who should execute this T1 task? T1 is for executing B1. B1 is present in S1. S1 only should execute. T2 is for executing B2. B2 is present in S2. S2 only should execute this. T3. T3 is present in S1. S1 only should execute this also. B4 in S2. S2 only should execute this. Means, if you observe here, S1 is there, S2, 2 slaves. S1 should execute to T1. S1 should execute to T3. S2 should execute to T2, T4. When T1 is executing, T3 will be in the waiting state. Here, T2 executes, T4 will be in the waiting state. Once this T1 and T2 execution finished, then T3 and T4 will be executed parallelly. So less speed right here. Say some tasks are in the waiting state. System 1 executing T1 means T2 should be in the waiting state. System 2 is executing means T4 should be in the waiting state. Means two tasks are in the waiting state. Okay. So here, less speed, less parallelism, right? Because T3 and T4 are in the waiting state. Two are executing, two are in waiting. Once they are done, next T3, T4 executes. Now observe this. Next case. Okay. Case 3. Observe this case 3. Number of blocks. More blocks, only one slave. More blocks, only one slave. Three blocks, one slave S1. Assume F1 dot txt 192 MB. Default block size 64 MB. Into how many blocks? 192 by 64. 3 blocks. B1, B2, B3. How they are stored across this cluster? Single master, only single slave. S1. B1 here, B2 here, and B3 here. F1 dot txt into how many? B1, B2, and B3 blocks. B1 stored by S1 only, B2 also stored in S1, B3 also stored in S1. This is how this data stored, right? And the data processing. Job to process F1 dot txt divided into tasks, number of tasks. Number of tasks equal to number of unique blocks. Number of tasks equal to number of unique blocks. How many blocks? 3 blocks. T1, T2, T3. Who should execute these 3 tasks? See, job to process F1 dot txt, 3 tasks. T1, T2, T3. T1 for executing, T2 for executing B2, T3 for executing B3. Who should execute T1? S1 only. T2, S1 only. T3, S1 only. All 3 tasks, T1, T2, T3, are executed. sequentially by a single slave. All three tasks T1, T2, T3 are executed sequentially by a single slave S1, right? So here you won't see parallel processing. Observe in the case one, in the case one, three tasks, three slaves. Each task takes 1 hour. Each task takes 1 hour. What is the total time taken? Three tasks executed by the three slaves parallelly takes 1 hour, right? Three tasks are executed by the three slaves parallelly. So in 1 hour, all the three tasks gets completed. Case two, four tasks. Okay, assume that here also four tasks, four slaves. Four tasks, four slaves. It takes 1 hour only. But here four tasks, two slaves. Slave one should execute two tasks, slave two should execute two tasks. So it takes 2 hours. Case three, four tasks, only four tasks, only one slave. It takes 4 hours. So what is your observation? If more slaves, more speed. If less slaves, less speed. If only one slave, no parallel processing. Yes, we can go, we need to go with sequential processing. Here I got some couple of queries. If you have got any queries, you can unmute yourself and you can ask the queries, or you can type in the short panel, right? I will go back to this case one, right? T1, T2, T3 are executed by the three slaves, S1, S2, S3. Suddenly, if S2 is down, three tasks T1, T2, T3 are executed by the three slaves, S1, S2, S3. Suddenly, if S2 is down, you can observe two things here. You observe two things. If three tasks T1, T2, T3 are executed by the three slaves, S1, S2, S3, suddenly S2 is down means this 10 lakh records, 10 lakh records are lost. Second thing is this T2 task is failed, means job also gets failed. Okay. Data is lost, 10 lakh records are lost. Second thing is T2 task is failed. Then how Hadoop is able to overcome this kind of situation means that's got a concept called replication and fault tolerance. Replication and fault tolerance. Right, 1 second. Replication and fault tolerance. Replication, nothing but a duplication. Replication is nothing but a duplication. Default number of replications in Hadoop. Default number of replications, replicas we say. Default number of replications means replicas. Default. We can also increase or decrease the replication strength. We can increase to 4, 5, 6, depending upon the security of this, right? Okay, default replication and fault tolerance. Replication nothing but duplications. Default number of replications means replicas equal to means observe using what is this replication and fault tolerance means f1 dot txt assume size 192 MB. Number of blocks 192 by 64. Three blocks. Three blocks means B1, B2, B3. Means replications or duplications are applied on this. B1 by 3 times, B2 by 3 times, B3 by 3 times. Totally 9 blocks. How these 9 blocks are going to be stored across this cluster? Okay, this is a master node. How these 9 blocks are distributed across the 3 slaves means B1 here, B2 here, B3 here. Again B1, B2, B3. Again B3, B1, B2. 9 blocks distributed across the slaves. Here f1.txt has to maintain, right? Which blocks are stored in which slaves, that information should be available. Okay, B1, B2, B3. B1 stored in S1, in S2, and in S3. B2 also stored in S1, in S2, and S3. B3 also stored in S1, in S2, and S3. Job to process. Now job processing. Now processing, right? Job to process f1.txt always depend number of job is divided into tasks. Tasks number of tasks equal to number of unique blocks. How many unique blocks here? 9 or 3? 9 means duplicated. Three times they are duplicated. 3 blocks only, 3 tasks only. Okay. Job to process f1.txt divided into T1 task, T2 task, T3 task. T1 for executing B1, for executing B2, T3 for executing B3. Who should execute this T1 task? S1 can execute, S2 can execute, S3 also can execute, right? Because the B1, B2, B3 is present in S1. T2 task also can be executed by S1, S2, and S3. T3 also by S1 or S2 or S3. Previously, B1 is present in S1, so S1 only should execute that B1. But here, All are present in all the slaves, right? Okay. So assume to execute this T1 task, master node has selected S1 only. So S1, S2, S3, all the three can execute, but S1 only. For T2, S2 only selected. For T3, S3 only selected. For T1, S1. For T2, S2. For T3, S3. Okay. Three tasks. T1, T2, T3. T1, T1 by S1, T2 by S2, T3 by S3. Understand here, three tasks. T1, T2, T3 are executed by three slaves. S1, S2, S3. Suddenly, if S2 is down, suddenly if S2 is down, do you see any data loss here? There is no data loss, right? Still the B1, B2, B3 is available in the other slaves. So first thing is there is no data loss. Second thing is this T2 task will be assigned to either T1 or T3. So anyone has to execute this two tasks. So here the job is not failed and the data is not lost. So because so multiple tasks, when multiple tasks are executed by multiple slaves, suddenly if any one slave goes down, then the task of that slave will be assigned to any of the other slave. This process we call it as fault tolerance mechanism. When multiple tasks executed by multiple slaves, suddenly if any one system goes as their machines, then the task of that will be assigned to other slaves. This process is called fault tolerance. And replications, you understood it? Three times replications. Yes, yes. Fault tolerance, who is going to take care? The master node. Master node is going to take care. It's automatic. We are nothing to do anything, right? So just only thing what you need to do is how many replications you want, you need to specify. Three replications or four replications or five. Means how many duplications required. B1 by three times, B2 by three times. This thing you need to specify. How many three or four or five. Remaining everything taken care by the master. Here I got two queries, two couple of queries, right? This T2, once this S2 is down, the T2 task will be assigned to T1 or T3, S1 or S3. Which one? To which one it will be assigned? What is the criteria followed in that assignment? That is one. And one more, T1 task can be executed by S1, S2, S3. Why you have given the preference to S1 only? How this task is assigned to, how to assign a task to a slave? What is the criteria followed? So just observe this. Okay. S1, S1 slave 1 executing T1 task. S2 executing T2 task. Slave 3 executing T3 task. Suddenly this T2, this slave 2 is down. Then T2 should be assigned to S1 or S3. To which system, which slave? What is the criteria followed, right? Here we got 4 steps criteria. 4 steps criteria, right? First one. To which slave this T2 should be assigned to S1 or S3. What is that? 4 steps means master node selects which has master node selects the slave which is highly configured. Master node selects the slave which is highly configured means which has got high hardware configuration. If both have got the same hardware configuration, if both S1 or S3 will have the same hardware configuration, then master node selects master node selects the slave which is more free, which is more free or more ideal. Master node selects the slave which is more free among this S1 and S3, which is more free. S1 executing already 4 tasks, but S3 executing only 1 task, then assign to S3. Don't burden S1 by assigning one more task. Next time. Assume both the slaves are free. Then master node selects the slave which is nearest to it. Means one slave can be in one country, another slave in another country, another slave in another country. Otherwise, within the same state, master node selects the slave which is nearest to it. Nearest to it means they can be in different countries, they can be in different states, they can be in different cities, they can be in same within the same lab also, right? If they are equally near, if they are if S1 and S3 are both are equally near, then master node selects the slave which has good health status. Good health status means uh, if both have got same hardware configuration, doesn't mean that both has got good health. Means there might be some software issues or hardware issues in any of that. So which has got good health status, that will be selected. Okay, fine. But if both the slaves have got good health status, in that case, in the extreme case, it selects any one slave randomly. Any one slave randomly, right? Yes. Okay. Understood, right? How the storage and processing is happening. Any queries you have got, anyone briefly in asking that? You can unmute yourself and you can ask through voice or through chat. Yes. So clear notes available for what all we have discussed, right? So for example, so configuring, even if you want to configure, increase or decrease the block size, if you want to increase or decrease the block size, we should go to the Hadoop installed folder. In the conf, you will have hdfs-site.xml. Open this file, right? And just to give this configuration / configuration. Property / property. Name / name means within the configuration tag, property tag. Within the property tag, name of the property. Name / name. dfs.block size. Value 50. Okay, fine. So how to increase or decrease the block size? How to set our own block size? Here I am setting to 50 MB or 200 MB or 100 MB or 90 or 70, whatever you want, right? So property / property, name / name, distributed file system dot block size. How much you want, you can set. So I was saying, right, case one, if number of blocks equal to number of slaves, full parallelism, right? So this notes, clear notes, data processing. 4 tasks are executed by 4 slaves. Here no task is in the waiting state, full parallelism. If the blocks are more, slaves are less, less speed, right? So here S1 executing 2 tasks, S2 executing 2 tasks. So here some 2 tasks are T1, T2 are executing, but T3, T4 will be in the waiting. But in the case 3, all blocks are stored in a single slave. So all the tasks should be executed by T1, T2, T3, T4 are executed by one slave sequentially, one after the another, right? Replication and fault tolerance, right? Default number of replications, replicas in Hadoop 3. We can configure or increase the replications also. Here, replications. The file size is 192, 64 MB, 3 blocks, B1 by 3 times, B2, B3 by 3 times, 9 blocks. So here T1 task for executing B1, S1, S2, S3 can execute this T1, right? And this is what we have discussed. And what is the criteria followed in assigning a task to the slave? Yes, if S2 is down, then S1, what is the criteria followed, right? We have 4 steps criteria. Master node selects the slave which is highly configured, which has high hardware configuration. If which has high hardware configuration. Second one, which is more free, more ideal, right? Which is more ideal or more free. Master node selects the slave which is nearest to it. Master node selects the slave which has good health status, right? Yes. And master node selects any slave which is slave randomly. Fine. So this
So,
nodes, yes, yes.
for example, our slave one is having 1 terabyte of space, right? So we can store multiple files in slave one,
Hmm.
and we can process multiple files together, right?
Yes, multiple files can be stored, right? So in file one, only one B1 block data only stored. Next, after 2 days, file two you are storing, and in that also some block is stored, one block.
That is, we can process multiple files at the same time.
Multiple files, multiple files also, yes, multiple jobs can be triggered at the same time, yes.
Okay.
Multiple jobs means for executing multiple files. They can be executed parallelly, yes.
Okay.
So multiple systems will be running parallelly, right? Executing this, right? Yes, 1 second. Okay. So tomorrow we'll continue more on this, right? More discussion on this. Tomorrow I'll be discussing about the architecture, right? Architecture I'll be discussing, right? Yes. So yes, you can see in the chart, right? Yes. Yeah. Uh, the contact details of the online team. You can see, yes. Yeah. So you are supposed to get enrolled, right? Tomorrow the link will be changing, right? You will be getting a new link. So tomorrow the time will be, you'll be starting at 6 p.m. The class will be at 6 p.m. A new link you will be getting to your mail IDs, right? You'll be getting a new link to your mail IDs, right? So just get enrolled for this course, right? I said it's consisting of Hadoop, PySpark, Linux, Python, right? The fee structure is 15K. You can see in the chart the payment details and that the things, right? Yes, you can see in that. Okay. The form payment details, the contact details of the online team, everything you can see, right? Yes. Yes, sir. Yes, sir. From tomorrow onwards, right? Tomorrow onwards, once you got enrolled, right? Once you got enrolled, you will get a new link and to your Google Drive from tomorrow to your Google Drive, you'll be getting the every video, right? You'll be getting the videos to your Google Drive from tomorrow onwards. And notes you'll be getting to your mail. I'll be forwarding this clear notes to your mail. And a WhatsApp group will be created tomorrow. A WhatsApp group is going to be tomorrow for technical discussions. Yes, go to your Google Drives, getting the videos, your Gmail notes, and a WhatsApp group, right? Will be created tomorrow. For all this, right? First, you need to be enrolled for getting the new link also, right? To your mails, right? Fine. For data engineering. Okay. So tomorrow, from tomorrow, you'll be getting all these things, right? Notes, videos, and a WhatsApp group in the tomorrow of during after tomorrow session, right? You'll be getting all these things. So if you're already enrolled, if anyone already enrolled, right? Check your by tomorrow morning to your Google Drives, you'll be getting the videos. By tomorrow 10 o'clock, 10 a.m., you'll be getting that videos, yes, notes, and will be added into the WhatsApp, right? So get enrolled. Yes. Tomorrow we'll continue more discussion on this. Tomorrow class at 6 p.m., right? Yes, 6 p.m. in the evening. Yeah, any other queries, right? Anyone from your? Okay, fine. Tomorrow you'll get a new Zoom link to your mail IDs, your email, new link, right? New link. That link you need to follow, right? Up to the end of the course, right? New link you will be getting to your mail IDs and a WhatsApp group also will be created, right? Yes. Fine. Okay. Fine. I'm stopping for now. We'll continue tomorrow at 6 o'clock, right? So thank you all.